Welcome to our journey to the mysterious world of black holes. These enigmatic and perplexing objects have captivated scientists and the public alike for decades. But what exactly is a black hole? Well, a black hole is a region of space where the gravitational pull is so strong that nothing, not even light, can escape its grasp. They are like cosmic vacuum cleaners, sucking in everything that comes too close to their event horizon. But that's just the tip of the iceberg. Black holes also hold the key to some of the most fascinating and mind-boggling mysteries of the universe. From time travel to parallel universes, black holes open up a world of possibilities that we are only just beginning to explore. So, join me as we dive into the heart of darkness and explore the awe-inspiring and terrifying world of black holes. First, let's start by exploring the different types of black holes. There are three main types: stellar, intermediate, and supermassive. Stellar black holes are formed when a massive star collapses under its own gravity, while intermediate black holes are thought to form from the merging of smaller black holes. Supermassive black holes, on the other hand, are found at the center of most galaxies, including our own Milky Way. But what happens when something gets too close to a black hole? Well, as we mentioned earlier, the gravitational forces are so strong that nothing can escape its grip. As a result, anything that gets too close, planets, stars, even entire galaxies, will be ripped apart and pulled into the black hole's event horizon. This is known as spaghettification, where an object is stretched out like a piece of spaghetti. But black holes aren't just horrifyingly destructive forces of nature. They also hold the key to some of the most intriguing phenomena in the universe, including time travel and parallel universes. According to Einstein's theory of relativity, time can be warped by gravity, and black holes have an incredibly strong gravitational pull. This means that if you were to get close enough to a black hole, time would slow down to a crawl or even stop altogether. Moreover, some physicists believe that black holes could serve as gateways to other universes. This theory posits that a black hole can create a wormhole, which is a shortcut through space-time that connects two otherwise distant points. Well, the idea of traveling through a black hole can sound like science fiction. The possibility of discovering such a portal to other dimensions is what keeps scientists excited about studying black holes. Let's dig deeper into the formation of black holes. Stellar black holes are formed when a massive star runs out of fuel and its core can no longer sustain nuclear fusion. The star will begin to collapse under its own gravity, and if it is more than 3 times the mass of our Sun, it will continue to collapse into a singularity, a point of infinite density and zero volume. At this point, the star has become a black hole, and its gravitational pull is so strong that it can pull in other nearby stars, dust and gas. But how do we know that black holes exist if we can't see them? We can't directly observe black holes, but we can study their effects on nearby objects. For example, if a star is orbiting an unseen object and we notice that its orbit is irregular, we can infer that the unseen object is a black hole. We can also observe the effects of black holes on light. When a star passes too close to a black hole, the gravitational forces bend the star's light, creating a distorted image. This phenomenon is known as gravitational lensing and is one of the ways we can detect black holes. Another interesting property of black holes is their size. Well, their mass can be enormous. Their size is relatively small. A black hole with the same mass as our Sun would have a diameter of only 6 kilometers, which is about the size of a small town. On the other hand, a supermassive black hole with a mass of a billion suns would have a diameter of only 12 million kilometers, which is still relatively small compared to the size of a galaxy. Speaking of supermassive black holes, let's talk about Sagittarius A, the black hole at the center of our Milky Way galaxy. It has a mass of about 4 million suns and is located about 25,000 light years away from us. Despite its enormous mass, its event horizon is only about 17 times the diameter of our Sun, making it relatively small compared to other black holes. Scientists have been studying Sagittarius A for years, and recent observations have revealed that there are multiple small gas clouds orbiting around it. This discovery has given us more insight into how black holes treat matter and affect their surroundings. Now let's talk about the lifespan of black holes. Eventually, black holes will start to evaporate due to a process called Hawking radiation. This phenomenon is named after the renowned physicist Stephen Hawking, who first predicted it in 1974. According to his theory, particles and antiparticles pair and materialize near the event horizon of a black hole. One particle falls into the black hole while the other escapes into space. This process results in the black holes losing mass over time until it eventually evaporates completely. However, for stellar black holes, this process takes incredibly long, about 10 to 67 years, making them practically eternal. As we continue to study black holes, we discover more and more fascinating properties. For instance, we've learned that black holes are not entirely black. They emit radiation, albeit very faintly. This radiation, called Hawking radiation, was an unexpected prediction of how black holes behave and is one of the many ways scientists have been able to study these elusive objects. But perhaps one of the most intriguing discoveries in recent years is the detection of gravitational waves from the collision of two black holes. In 2015, the Laser Interferometer Gravitational Wave Observatory detected gravitational waves ripples in space-time from the merger of two black holes, which were about 29 and 36 times the mass of our Sun. This discovery provided direct evidence of the existence of black holes and confirmed Einstein's theory of general relativity. So, there you have it, black holes, the awesome and enigmatic objects of our universe. From their ability to consume entire galaxies to their mysterious properties that could unlock the secrets of time travel and other universes. Black holes are truly the stuff of science fiction turned science fact. But one thing is for certain, as we continue to probe the depths of space and unravel the mysteries of the cosmos, black holes will remain one of the most fascinating and intriguing objects that we'll encounter. And who knows what else we'll discover as we explore these cosmic monsters. The possibilities are truly infinite.